Hello everyone, this is our first remote learning experiment. It's a 2-week experiment in class, so what I'm going to do, I'm actually going to make it due in 3 weeks. So I'll give you a week to do the first part, a week to do the second part, and then a week to get everything together. So, you know, no rush on these labs really, because we're only going to do 3 and this actually will count as 2. Okay, so the lab in question, and please go and download and print the handout because you'll need to send a copy of that back to me later. Okay, so the lab is titration of a carbonate. Now I'll post these notes, you know, at the discussion section as well. But you know, just follow along. Pretend it's like a pre-lab from the classroom. All right. So it's a 2-part experiment. One, which is what we're going to concentrate on today. We're going to do a titration, so we're going to standardize a solution, which means essentially we're going to find its exact concentration. So we'll do a first titration, just like in Chemistry 101, maybe even in high school. The first titration to find the exact concentration of an acid, which we'll use for part 2. Okay, and then, you know, later on we'll talk about this in a separate video. Talk about the titration of an unknown. Okay. Now, apologies for the camera setup. I've been asking, for a better lens from the department, but no go. All right. So, bottom line is, we're going to find objective percent Na2CO3 in an unknown sample. Okay, so we're going to find how much potassium carbonate in an unknown sample. Now, that's a percent mass. Okay, so it might be like table salt and sodium carbonate 50-50 or something, and it's actually unknown, so you're going to have to tell me that number from your calculations. All right, now, good news is sodium carbonate solid is a strong electrolyte. It will completely dissolve to give you 2 sodium and 1 carbonate ion. Okay, now if you think about it, carbonate is the conjugate base, i.e. it's a base, right, of carbonic acid, H2CO3. So if I have a solution with carbonate in it, which I've just made by dissolving sodium carbonate in water, okay, it will react with water, because there's water in there, so CO3 2 minus, it will act as a conjugate base to make HCO3 minus plus OH minus. So the bottom line is a solution of sodium carbonate by itself is basic. So if you, let me move that up for you. So if you throw a pH probe in there, boom, it'll probably come out around 10 or something because it's basic. All right, so that's what we're starting with. We're actually going to take some unknown and we're going to dissolve it. Okay, so if you look at your procedure, that's exactly what we're going to do. All right, now that's down the road though. That's next week. Okay, that's the idea. We're going to titrate that with sodium hydroxide. Sorry, we're going to titrate that with HCl, and we'll do a nice titration curve. But first, okay, let's turn over the page here. But first, what we're going to do, if you think about it, we're going to have to do a titration. So in week 1, concentration of HCl. All right. So very simply, we're going to do a standardization. If you look at your practice data set, here it is, okay. This is data set number 6, you're going to get different ones, okay. So let's talk about the math here. First, we're going to find the concentration of some sodium hydroxide via titration with KHP, which is what's called a primary standard. Show you that in a second. And then once we got the value of the concentration of sodium hydroxide, we can then take it on to find the concentration of the HCl, which we'll need for our final titration. So a lot of titrations, as long as you keep it straight, it's pretty straightforward. Alright, so here's the standardization. KHP is a nickname, okay? I want you to look that up. That is not phosphorus, it's phthalate. It's the phthalate ion, it's an organic ion, okay? So be careful with that, okay? That's phthalate. So KHP is in speech marks, right? Okay. Plus sodium hydroxide, we'll dissolve that, okay? Turns into NaKP plus H2O. It's in a 1-to-1 reaction. Therefore, at the end point, moles KHP equals moles NaOH. Now, even though I've written that as aqueous, KHP actually comes in a powdered pure form, okay? And then we dissolve it, and you can read about that in the procedure. But the bottom line is, think about it. So moles KHP equals moles NaOH. Molecular weight grams moles equals CV. Therefore, grams KHP, which if I get back over here, boom, okay, this number, okay, divided by molecular weight KHP. Double check that, it's actually 204 grams per mole if memory serves. Okay, you'll double check that. Alright. Equals concentration times volume, concentration NaOH times volume NaOH. Okay, careful there, that's got to be in liters, right? Okay. Therefore, when we use our data, we want concentration of NaOH, grams KHP, I think it was 204.2, but double check that, grams per mole, times, if you think about it, bring this over there, 1 over volume NaOH. Now, that's got to be in liters though, remember, okay, because moles per liter. Alright, so work it through. There are your numbers, okay. So we have grams of KHP, check. Grams per mole. And then final volume, initial volume. Make sure you convert that to liters and boom, you got it. So it's going to be approximately 0.1, but I want you to give me 0.1 and then 2 more sig figs. Alright. Okay, so work out an average. And you're good. Oh, move that up so you can see it. So, you know, feel free to pause. That's week 1. You have a very simple titration, 1-to-1 reaction. KHP, which is basically a solid acid in the pure state. Sodium hydroxide, 1-to-1. At the end point, when this would change color, when you use up all the acid, when titrating with base, moles equals moles, 1-to-1. Hey, moles equals CV for a solution, grams divided by molecular weight for a solid. Rearrange it. Good to go. Okay, so find an average, and we'll take that to part 2. All right. So in part 2, if we take a quick look at the data sheet here, Okay. We have a standard titration again, but now with the stuff from above, with the stuff we're going to use for our actual unknown. Okay, and this one, pretty straightforward. Moles HCl equals moles NaOH at the end point. I'm not going to write HCl plus NaOH balanced equation, that's given, right? So therefore, concentration HCl times volume HCl equals concentration NaOH, volume NaOH. Alright, so we want concentration. Now because this and this are in milliliters straight from the burette, there is no need to turn it to liters, because if you think milliliters will cancel. Okay, so C NaOH, that was from part 1. Volume NaOH. Initial minus final, right? 3 trials. Over volume HCl. Now volume of HCl, it's on the sheet there. There it is, okay? Again, all right. So do 3 trials, take an average, HCl. All right, so honestly, I mean, if you look back at your Chemistry 101 or even high school stuff, this is simple acid-base titration. What I want you to do in this first week is get, at the end of the day, the concentration of HCl. It should be 0.1 with 2 more significant figures. You might get 0.099 or something like that, but something around 0.1. That's how we figured it out in the work here. All right, so give that a shot. Bring stuff up in discussion if you have any problems with that. But I want everybody in this first week to get the concentration of HCl for their particular data set. There are 6 data sets. I'll send you all something different. Okay, so yes, feel free to talk to each other, but essentially, you're going to hand in your own lab on this one. Okay, so try and figure it out. All right, let's stop there. I'll get all this posted.